Okay, good. So in practical terms, right? So here we're looking at things like what is the action noun corresponding to the agent noun directeur? Okay, and now I'm asking, what does the meaning of directeur tell us about the meaning of direction? Okay. Okay, so oh, but I have lost this. What do I need to do? Oh, yes, thank you. Okay, so what are our expectations? Okay, if derivational morphology is just about rooted trees, what we expect is that derived forms should be typically predictable from their base, and we don't expect derived forms to be predictable from other members of the derivational family. Okay, so for instance, well, sometimes things look exactly like that. Okay, so if you take the French verb verser, which can mean to pour or to transfer, okay, it has two derivatives. So versement, which is an action noun, which means payment, and verseur, which is an agent instrument noun, which means pouring instrument or agent. Okay, and clearly you see that the polysemy of the base was not transferred to the derivatives, so that one is specialized for a special kind of transfer meaning, the other one is specialized for a pouring meaning, and so the predictability relationship between the two derivatives is low, okay, because these two decisions were taken independently of one another. On the other hand, they're relatively, the relationship with the verb is relatively clear in both cases. Okay, so this case is exactly the kind of thing that we expect to happen with a tree-based model, and we expect that this is the kind of behavior that we see across the board. Sometimes everything will be transparent and interpredictable, but if there's opacity, the opacity should be among derivatives. Okay, what we don't expect is situations where this does not hold, and we have strong predictability derivations among derivatives that does not extend to the base. Okay, and this example that I already showed of social, socialism, socialist is illustrative of the fact that this can happen. And well, to kind of make my point that one is easy and the other is not, I've shown you here the definitions of the two terms in the Oxford English Dictionary, and I think this makes it pretty clear that the relation between social and socialism is quite intricate, while the relation between socialism and socialist is straightforward. Okay, so you can think about it at length, but just the difference in length of these two paragraphs is illustrative of what I'm after. Okay, oh, okay, so the crucial thing is that, well, if this is just anecdote, we don't care. Okay, so what we care about is, do we find systematic evidence for these kinds of effects? Because if it's anecdotal, if it's just a few random examples, again, the lexicon is messy, all kinds of things can happen, right? So what we want to know is, can we find systematic evidence for this? Okay, so we're going to try to do this using methods from distributional semantics. And so I have a small parenthesis here to say a few words about distributional semantics. For those of you who are not too familiar with it, you can do something else for 3 minutes if you are familiar, because this is going to be very basic stuff. So the idea of distributional semantics is, so it's grounded in the distributional hypothesis, which is an old idea, but I'm using modern formulations because they're easier to make sense of from today's point of view. So we start from the observation that similarity of meaning results in similarity of linguistic distribution, which is obviously true. And then we make the hypothesis. So this is where the hypothesis comes in. We make the hypothesis that because this is true, the degree of semantic similarity between two linguistic expressions is a function of the similarity of the linguistic contexts. Okay, so it's taking that relationship in the other direction. So this is by no means a new idea. It dates back to Harris, but it has become practical and very efficient with the advent of word embedding technology. I want to make two important points, extra points. One is that it does not need to be literally true to be useful. If you take the term function seriously from a mathematical point of view, this is almost certainly false, okay? But this could still be a very useful approximation, even if it's not literally true, okay? And in addition to this, it's not really about semantics. It's about everything except form, okay? And so when we're doing morphology, distributions capture not only semantics, but also aspects of morphosyntax that are relevant. Okay, and so actually this is very convenient for me because I don't need to make a distinction between the two. My distributional information is going to capture holistically both semantics proper and morphosyntactic information, and that's fine because this is the whole thing that I'm contrasting with form. Okay. Okay, so the basic technical idea then is just to see co-occurrence counts in a corpus as vectors and angles between vectors as measures of similarity. So if you have this toy example of we have 3 words here, we're looking at their co-occurrence with 2 other words, counting up how often they occur in a corpus, and then we can take these to be dimensions in a vector space. And this tells us that, well, we have the vector for student, which is very long and vertical, the vector for car, which is shorter and horizontal, and computer is somewhere in between. And this kind of matches a semantic intuition that a computer shares properties with a car and shares properties with a student. Of course, this is not how it's done in practice, because we need many more dimensions. And also, nobody works with co-occurrence counts anymore in practice. But in terms of the intuitions that this captures, it doesn't really matter to us. So for our purposes, the best distributional vectors that we can find are the ones that we want to use, and who cares how they were obtained. It's not important from a linguistic point of view. Okay, now the relationship with morphology is, so there's one very important and direct relationship with morphology, which is that we can capture the content side of morphological relations by looking at difference vectors, by looking at the relationship between one vector and another one. Okay, and so these difference vectors tell us something about morphology. And so one point that we have established a few years ago in work with Denis Paperno is that the variability of difference vectors reflects the semantic predictability of the relation between pairs of words. Okay, in the context of that paper, we were looking at that from the point of view of distinguishing inflection and derivation. And what we showed is that when you look at these difference vectors for inflectional relations, they tend to vary very little, as do the 2 red vectors here that look very similar. Whereas if you look in derivation, you see a lot more variation, as you see in this toy example with the blue vectors. Okay, so this kind of shows that, yeah, there's relevant structure in these distributional vectors that we can build on to study morphological relations from the point of view of meaning. Okay, end of parenthesis. Back to our topic. Now that we know what the distributional vector is and the importance of difference vectors, what are we looking for to operationalize our question? We're looking for matched pairs of processes where we have a same base with 2 derivatives belonging to the same categories. Okay, and we're looking for cases where the picture looks like this. So if you look at this picture, so by hypothesis, our bases are the x's. Okay, and so you see that the relationship between x1 and y1 is very different from the relationship between x2 and y2. And the relationship between x1 and z1, second derivative, is very different from the relationship between x2 and z2. But the relationship between y1 and z1, the 2 derivatives, is very similar to the relation between y2 and z2. Okay, so we're looking for cases that look like that. So do we find cases where, on average, this is how things look? Okay, that's what we're looking for. Okay, so the details are tedious, so I'm going to try and go quickly over the details. We needed vectors. This is how we derived them. We needed lexical data. This is how we found it. So basically, we're going to look at, we took everything we could find in French that worked. So we looked at all processes for which we had good morphological resources giving us pairs of related lexemes. Okay, and we tried to pair them up with a common base and then 2 derivatives. Okay, and looked for cases where we had more than 150 instances where we could do this with non-trivial frequency, so that we also had a vector for the words. Okay, so this led us to 10 data sets. Okay, so comparing, so for instance, verbs and derivatives in age, these are action nouns, and then derivatives in based on the same verb, these are agent nouns. or verbs and derivatives, and or nouns, adjectives or nouns with derivatives in ism. And these are the ones we discussed earlier, and then corresponding nouns in ist. Okay, etc., etc. So those of you who worry about morphology might notice that some of these are rivals, and this is something that we can discuss if there's a lot of interest about it. But this is deeper into morphological analysis than I wanted to go. Okay, so now how do we proceed in practice? So that's the intricate part. One thing that we need, which is an idea that comes back down, that was first laid out by Marelli and Baroni. What we want to say is that when we look at a derivational process, we can describe its semantic import as a function that takes you from base vectors to derivative vectors. Okay, so a function that is such that the vector for explained leads to the vector for explainable, the vector for applied leads to the vector for applicable, etc., etc. Okay, and note that we can very easily generalize this to any paradigmatic relation across morphological families. Okay, so they took bases and derivatives, but we can exactly ask the same question about about two derivatives, right? So we can. If we have a way of estimating these functions, this should work both when we have a base and a derivative and when we have two derivatives. And then if we have such a function, we can then measure how good the function is as capturing the semantics of the process by taking one input vector, applying the function to it, then we have a predicted target vector, and then we measure the difference between this target vector and the actual vector for the derived word, for the output word. Okay, and so this average value, the average cosine value between the predicted and the actual vector, is indicative of how predictable the meaning of targets is for that particular morphological relationship. Okay, so then, well, how we compute that function? Many different ways of doing this. This is how we ended up. So yeah, there are simple ways of doing this. Marelli and Baroni use linear transformations for that to that effect. When we tried to do that, we had a lot of overfitting. So we tried to have something a little bit simpler, which was a single linear model that predicts one dimension of a vector in the predictor to the same dimension in the target, but adding in 10 principal components of the predictor vector. And this turned out to work pretty well. And we do systematic cross-validation to check for overfitting. Now, so we can apply that each time we have a base and two derivatives. So for each of our data sets, we can basically ask 6 different questions about predictability of semantics. The crucial cases for us are going to be the ones that I have highlighted here. Is D1 better predicted by the base or by D2 in blue? Or is D2 better predicted by the base or by D1? These are the crucial ones. I'm also going to report the other ones, but I have no analysis of these results at this point. Okay, so when we do this, we get results that look like this. So for accordé, for accordeur as it relates to accordé, we get a performance on that for that data point, and then we can average across all our cases of base to derivation, and then you get that average. Okay, and so similarly for the 5 other possibilities in that data set. Okay, now we could try and conclude by directly comparing these averages, but we don't want to do that directly because we're not too confident about the quality of our vectors and the quality of our functions. So we want to have an estimation of how certain we are about our averages. And so for that purpose, we, on top of this, use a Bayesian regression to have credible intervals across our estimated means. Okay, so yeah, lots of preliminaries, and now I can show you what it looks like. Okay, so this is for verbs, agent nouns in action nouns in ment. Remember that this was just by coincidence, my example of a case where things might go in the direction of the rooted tree approach. Okay, so importantly, if we compare, so this is predicting more from the base, and this is predicting more from and you see that we get clearly better performance when predicting more from the base than predicting more from okay? And if we now look at predicting we also get better average performance when predicting from the base than predicting more from the base, although the evidence is not so clear how credible intervals overlap. Okay. Okay, so this goes exactly in the direction that would be traditionally expected. But just by chance, we go to another case, which is ISM and IST, and we see exactly the opposite result. So now we're comparing here ISM predicted by IST compared to ISM predicted from the base, and now prediction from the other derivative leads to a more accurate result. Okay, and likewise in the other direction, IST predicted by ISM leads us to a much better cosine estimate than IST predicted by the base. Okay, so this is exactly the kind of evidence we were looking for of a situation where we have a paradigmatic relation that does some job for us and that is not captured by the tree structure. Okay. So in other cases, the evidence is more mixed. Okay, and that's largely for questions of lack of data. So this data set was smaller for Ye and Uri. And we see that, so this goes in the same direction as ISM and IST, but we basically don't have enough data to make any conclusion because all our intervals overlap. So yeah, if we have to guess, the tendency seems to be that the averages differ in the right way, in the interesting way, but the evidence is not compelling. Okay, so what did we see with this final study? So we have clear evidence that for some, but not all pair of processes, derivatives are more interpredictable than either is predicted from their base, importantly, on average. So it's not a matter of finding one cute example where this is the case. This is the average situation, okay? And this is directly contradictory with the rooted tree model and entirely compatible with a paradigmatic model. Okay, I'll comment more on that in the conclusion, in the general conclusion. Okay, so this is exactly what we're looking for evidence for that paradigmatic relations matter for semantics. Okay, so importantly, so the ISM-IST case is the one case where we found compelling evidence. And that's not very surprising if you know the literature about derivational paradigms, because this is the poster child for derivational paradigm. It's the case that everybody always discusses. So in a way, we're just confirming what everybody believed all along. But importantly, most of the literature is actually on those cases like optimism, optimist, or fascism, fascist, where there's no base. So that's where the argumentation usually lies, right? That we have many cases where there's no base, okay? And these actually do not participate in our data because we had to have a base to be able to make the computations. So we're making a different argument based on the same part of the data. We have a conclusion that a strong paradigmatic bond exists even when a base is present. Okay. This is all importantly, although this is just one data set among 10, this is exactly what we needed to prove our point. Remember, if you think about it, the paradigmatic hypothesis predicts that derivatives will sometimes be highly interpredictable, not that they always will. From the point of view of a derivational paradigmatic approach, all relations between pairs of morphological categories are paradigmatic relations. So it's not that it should always be among derivatives. The fact that sometimes relations between base and derivative are also strong, well, it's just another paradigmatic relation, okay? What is crucial is that for the rooted tree hypothesis predicts that bases should always be the best predictor, and that's what we showed not to be true, okay? Okay, on the other hand, well, I'm still not comfortable with having just one data point, right? With the fact that this is all dependent on ISM and IST in French, okay? And so I would be delighted to have more. And I would be delighted in particular if people who work on languages which happen to have orders of magnitude more data available than what I have for French were interested in doing that. That would be wonderful. Okay, and so yeah. just mentioning that to this audience. Okay, now to main conclusions. What I've tried to give you is substantial evidence of a systemic role of paradigmatic relations in shaping derivational families, with strong evidence from form predictability. So yeah, this is a research program that has been going on for more than 5 years now. So we have robust results at this point, and promising evidence from predictability of meaning, which is a new thing that we're trying out now. Importantly, the argument is not that only paradigmatic relations matter. So yeah, so of course, it's very hard not to take a polemic tone when talking about these things, but I'm not arguing that paradigmatic relations are the only thing that matters. I'm just trying to establish that they matter, right? So I'm not saying that you should stop worrying about other aspects, these aspects that are captured by the idea of a base derivative relationship. Actually, our data sets were designed predicated on having that information available, right? So it's not like we could even make the study without having that information, okay? So I'm arguing rather that we need to also pay attention to paradigmatic relations, okay? And so I'm also, this is something that, yeah, that I'm saying just for the purpose of this particular audience. I hope to have exemplified how computational methods are crucial to answering key theoretical questions in morphology by allowing one to move from anecdotal to systemic evidence. And that's an important point for the field of morphology. And hopefully that's also an important point for computational linguistics, that sometimes the goal can be to make progress in our understanding of linguistic systems rather than in applications. Finally, let me finish by pointing out that I have explored various facets of a three-dimensional search space. So I've looked at form and meaning. I've used computational and behavioral methods, and I've looked at inflection and derivation, although I talked about inflection just as an inspiration for work on derivation in this particular talk, okay? You might notice that there are some holes here. So there are some things that I have not done here. I have not done yet that would be interesting to do. So the last row in this table is a fascinating topic that would warrant a lot of future work. We're not there yet. This cell in the table is a little bit easier. And in fact, as some of you may know, we're actually in the process of doing exactly that. So we have some preliminary work with Łukasz Kijanek, who is here today, on looking at inflection in more or less the same terms as I've looked at derivation right now, looking at check nouns and adjectives. And so although this is not the topic that we're studying, one very striking result of that study is that we find that there's extremely accurate distributional predictability in inflection, that the cell-to-cell prediction is incredibly accurate if you have the right data. So I think that one of the reasons for this is that we're doing this based on Czech National Corpus data instead of crappy web data, but we get really extremely accurate results. So this is very promising as a method. But the thing that we're really interested in is to think about the structure of paradigms in terms of morphosyntactic features, thinking about the fact that feature systems convey assumptions that some contrasts in paradigms are parallel, okay? So if I call this singular and this plural, that suggests that the contrast between these two forms should be kind of the same as the contrast between these two forms, and the contrast between these two forms, and the contrast between these two forms. Okay, and so this is what we have looked at in detail, and what the preliminary conclusion that we have is that parallel contrasts are somewhat similar, but not as much as you would like, and that's kind of, again, an interesting result from a theoretical point of view. And I will stop here with this advertisement for the future, and thank you very much for your attention.
Well, thank you very much for the interesting talk, which really